Hello everybody. In this video let us see some formulas. Okay. He will ask in the questions and ask to identify that formula. So in that, first let us go for complex numbers. So a number such as a plus ib. If we take a number a plus ib, in this a and b we call it as real numbers. Okay, and here I an imaginary number and we wrote this as a plus ib, we call it as complex number, right? Okay, so now if we take example x plus iy, a complex number, then sum of this how we will write? X plus I, for example x minus I, x plus x 2x, iy minus iy. So what we got? The sum of complex number is a real. Okay, now if we see the product, same x plus I into x minus iy. So what we will get? X into x, x square minus x iy plus iyx minus I square y. What is I square value? Minus 1 only, no? So minus 1 means here what it becomes? X square, these two strikes off, plus y square. Again the product of complex numbers also we got it as real number, right? Now next, complex number is denoted by z is equal to, already I said, x plus iy. Okay, now let us write the complex conjugate. Conjugate means what we have to do? Just put, if plus I is there, minus I. If minus I is there, plus I. So z bar x minus iy. Okay. Now next, let us move for analytic function. So these are small basics which may be useful in bits. So what is analytic function? So analytic function, for example, f of z. So f of z is called as analytic function. At one particular point you think as z is equal to z naught. If this is a single valued at one particular point z equal to z naught. If this f of z function is a single valued and has derivatives at every point, then we call it as analytic function. Now let us see the necessary condition for function to be analytic. Let us see when it will be analytic at one particular point z equal to 0. If this function is single valued and have a derivative at every point, we call it as analytic function. Right? Now let us see the necessary condition for a function to be analytic at some point z. Then we will write dou u by dou x is equal to dou v by dou y, right? Or dou v by dou x is equal to minus dou u by dou y. So these both we call it as Cauchy-Riemann differential equation. What is Cauchy-Riemann differential equation? Remember it. Dou u by dou x is equal to dou v by dou y. Okay. Dou v by dou x is equal to minus dou u by dou y. Now let us write Cauchy-Riemann equation, differential equation in polar form. So in polar form we will write dou u by dou r equal to 1 by r dou v by dou theta. Right? Now next 1 by r dou u by dou theta equal to minus dou v by dou r. In polar form, what are their relations? Dou u by dou r is equal to 1 by r dou v by dou theta. 1 by r dou u by dou theta equal to minus dou v by dou r. Okay. Now next, let us move for some few preliminary concepts such as continuous arc. So continuous arc is defined as some set of points. If we take z is equal to x comma y, if this set of points satisfies z equal to x of t plus I y of t in range alpha less than or equal to t less than or equal to b, then x of t, y of t are continuous functions of the real variable, we will say. Here continuous arc means a set of points such as x comma y satisfying the equation z equal to x of t plus I y of t in the range alpha less than or equal to t less than or equal to beta. Then we say it as continuous arc. And here x of t, y of t, we call it as continuous function of real variable t. Similarly, multiple points. Now a point z1, if we take a point z1, it is said to be multiple point of arc if equation z1 equal to x of t plus I y of t is satisfied by two or more values of t, satisfied by two or more values of t in a given range. So if we take any point z, right, then if this equation z1 equal to x of t plus I y of t satisfied by two or more values of t in a given range, we call multiple points. Okay. Now next, Jordan arc. This is nothing but, now we started from initial point. So we are moving in such a way and came to initial point. So this we call it as closed curve. Right. Such a simple closed curves only we call it as Jordan curves. Or we can also say that continuous arc with no multiple points. No multiple points. Continuous arc. So arc is continuous. Only intersection is at initial and final point itself only. There is no other intersections at any point. Such we call it as Jordan arc. Now next, Jordan curve. Okay. So Jordan curve means Now it is a continuous arc defined as z is equal to x of t plus I y of t in the range alpha less than or equal to t less than or equal to beta t. Right? Now next, here x of alpha will be equal to x of beta. Y of alpha will be equal to y of beta. So if there are no other multiple point in continuous arc defined by 1, then this continuous arc is said to be Jordan curve or closed curve. Now let us see regular or smooth Jordan curve. Regular or smooth Jordan curve or Jordan arc, Jordan arc. If f of t and y of t, x of t and y of t are single valued functions of variables t and have continuous first order derivatives, these are single valued continuous functions of variable t and have continuous first order derivatives. Then we call it as regular or smooth Jordan arc. Okay. Now next, counter. This is nothing but a curve composed of chain of infinite. It is chain of infinite regular Jordan arcs. Infinite regular Jordan arcs. Now next, let us see the formula for Cauchy's integral theorem. Integral C f of z dz is equal to 0. What is Cauchy's integral theorem? Integral f of z dz is equal to 0. Next, Cauchy's integral formula. Okay, so integral formula, if f of z is analytic, right, single valued, and on a closed counter C, if z0 is any point within C and on a closed counter C, and if z0 is any point within C, then Cauchy's integral formula is written as f of z0 is equal to 1 by 2 pi I integral C f of z by z minus z0 dz. What? 1 by 2 pi I integral C f of z by z minus z0 dz. So what he will do in the exam is, he will give the options A, B, C, D. He will say, what is Cauchy's integral formula? So if you are perfect with this formula, 1 by 2 pi I integral C f of z, z minus z0 dz, then easy you can put the options. Okay. Now next, once let us see Taylor's series. So if we know the formulas, doing the problems also become easy on it. So Taylor's series, how we will write means, if f of z is analytic, Analytic means the functions which are single valued and have derivative at each and every point, then we call it as analytic. So these are given by Cauchy-Riemann equations only. So in starting only we read, right? So now if f of z is analytic at all points inside some circular domain D with its centers at z equal to z0 and radius as r0, then f of z is written as f of z0 plus differentiation of z0, that is f dash z0 1 factorial z minus z0 plus again double differentiation, again differentiate this given differentiation, f double dash z0 by 2 factorial z minus z0 whole square plus so on we will write until f double, or we can say f of n times differentiation z0 by n factorial z minus z0 whole to the power of n, so on. Or in a simple way we can write it as summation n equal to 1 to, from where we are starting, 1, no? Okay, 1, next square, next n, okay, we got n, 1 to infinity f of n z0 by n factorial z minus z0 whole to the power of n is the Taylor's series. What is Taylor's series? Summation n equal to 1 to infinity f of n z0 by n factorial z minus z0 whole to the power of n, right? Now next let us go for singularity. Sorry. A singularity function, if we take f of z, is a point at which function ceases to be analytic. For example, 1 by z minus 2 v2. It has a singular point at z minus 2 equal to 0 or z equal to 2. Okay, this is about singularity, right?